Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about integer exponents. We're going to be looking at exponents and positive and negative exponents today. We're in the Expressions and Equations Common Core Standard, and today we're going to use the properties to create expressions that are equal to each other and solve real-life problems with these expressions. Specifically with exponents, we're going to talk about how we can find a number with an integer exponent. You've done positive numbers in the past. Now we're going to look at negative numbers. Here's a couple examples of where you might see exponents. One in particular, the diameter of Jupiter. Have any idea how big Jupiter is? It is huge. It is huge. The diameter of Jupiter is 10 to the 8th meters. What that means is a 1 with 8 zeros on the end. A 1 with 8 zeros. Pretty crazy, huh? That's really, really big. Now, can you imagine the diameter of an atom? Well, you've seen things like the diameter of Jupiter before with a positive exponent. When we're looking at the diameter of Jupiter, we're going to be putting a negative exponent. And the diameter of an atom is about 10 to the negative 13th. And what that means is it's a decimal point with that many zeros in front of the 1. So you look at here, you put the negative 13. That means 1 over 10 to the 13th power. So it's a little different, and we'll talk a little bit more about how that works here in just a second. But that's where we'll see exponents a lot, is with space, as well as when we're using like microscopes and digging down smaller and smaller. All right, so positive and negative exponents. We're going to be looking at these. When you have a negative exponent, usually what that means is the number is extremely small. Well, let's look for a pattern here. Let's talk about this. You guys all can find a pattern from this, right? 4 to the third. Well, how do you go from 4 to the third to 4 squared? Well, if you think about it, there is one extra 4 here than there is here. So how do you go from the 3 to the 2? How do we do that? Can you think about it? Well, we're going to divide by 4. So if you think about it, from the 3 to the 2, there's one extra 4 on top than there is on bottom. So we're going to divide by 4. Well, if we follow this pattern, how do we go from 4 squared to 4 to the first power? Well, we do the same thing. We divide by 4. So going from, notice we've got the 2 up, the 3 there, to the 2, to the 1. Each of the time we go down 1, we're dividing by 4. So how do we go from 4 to the first power to 4 to the 0 power? What is 4 to the 0 power? Any idea? Well, if you continue the pattern of dividing by 4, let's look at it. 4 to the 0th power, we're going to divide by 4. It's 4, 1 over 4. So 4 to the 0 power is not 0, it's just plainly 1. Anything to the 0 power is 1. Pretty simple, huh? All right, well, how do we keep going? Let's go down to the negative exponents. Well, the pattern was that we subtract 1 each time we divide by 4. So now the next one's going to be 4 to the negative first power. So remember, you've got 1 over there, and then we're going to divide by 4. So in essence, it's just 1 over 4 to the first power. All we did was take the negative away and put a 1 over it. We're going to do the same thing for 4 to the negative second power. We're going to divide by 4. So can you imagine what this one's going to be? It's going to be 1 over 4 squared, or 1 over 16. And that's the pattern. So pretty easy when we're solving for negative exponents. You just put a 1 over it and get rid of the negative in front of the exponent. All right, if you remember this and recall this in the past, 4 to the 5th over 4 to the 3rd, if we're going to divide these two, really simply put, it's just 4 to the 5th minus 4 to the 3rd. You just subtract the 5 and the 3. Well, then that becomes 4 squared. The other way to look at it too, so if you have it flipped around where you put 4 to the 3rd on top and 4 to the 5th on bottom, you subtract the 2 and you get 4 to the 3 minus 5, and that becomes 4 to the negative 2, which then in essence is 1 over 4 squared. Pretty simple, huh? All right, why don't you look at these guys, see if you can figure these ones out. All right, how'd you do? Well, notice on number 2, the negative exponent's in the bottom. Well, to flip it around, you just put it on top and get rid of the negative exponent. 3 is tricky. If you think about it, you just bring the 3 to the top. If you do the subtracting of the exponents, 2 minus negative 2 becomes 3 to the 4th. All right, here are your answers. When you simplify it, definitely simplify it down, get rid of the exponent once you have got the final exponent ready. Multiply it out. All right. Well, the same goes for negative exponents with variables. The same pattern arises. So if you notice, if you got x to the negative 3, if you think about what's going to happen, you just put a 1 over it, get rid of the negative, and it becomes 1 over x to the 3rd. Not bad, huh? All right, look at this one. 2x all to the negative 3rd power. Well, again, put 1 over it, get rid of the negative, and then now what you're going to do is you're going to cube 2 and cube x. So it becomes 1 over 8x to the 3rd. Next time, what we're going to do now is 3x to the negative 3rd over x to the 4th. All right, if you subtract it, that's usually going to be a little bit easier way. It's 3x negative 3 minus 4 becomes 3x to the negative 7th, which becomes 3 over x to the 7th. One of the other things we can use this is called scientific notation. We've used this in the past. We've looked at it, especially with big distances like the diameter of Jupiter, or small distances like that of the diameter of an atom. Scientific notation is a number written as a product of a factor and a power of 10. So look there, it's 2.7 times 10 to the negative 8th. That's simple. You've got a number times 10 with the exponent. And notice how the number is 2.7. It's not 27, or it's not 270, or 0.27. You always want to have one significant digit in front of the decimal point. So for example, this one is not written in scientific notation. This one's bad. So what we can do, though, is we can flip it, move the decimal place over once, and then add another exponent to the top. Notice it's now 10 to the negative 8th. And what that means then is you've got 1, 2, 3, 4, 5, 6, 7 zeros in front, and the decimal place goes that far to the left. That's called scientific notation on the left, and the standard form is on the right. If you're ever asked to find it in standard form, it's just actually multiplying it out. All right, let's try this one. We've got 27 times 10 to the 7th. Is that written in scientific notation? Well, if you said no, you're right on. You've got to make sure there's one decimal place in there and one number in front of the decimal place. So what we'll end up doing is we'll take a big old green X, put it on there, and put 2.7, move the decimal place over one more, and do it 10 to the 8th. So now what happens is you look over to the right, to the number on the right, you've got 1, 2, 3, 4, 5, 6, 7 zeros, and then the 7 includes 8 decimal places. All right, why don't you try these guys? A micrometer is 1 times 10 to the negative 6th meter. How many micrometers are there in 20 meters? Set up a proportion if you need to. Might be helpful. And then number 2, write this number in standard form. Would you do that for me, please? And then on 3, you're going to write the number in scientific notations. Definitely remember, you move the decimal place all the way in, so you've got one number in front to the left of it, and then you count how many spaces you moved that decimal place, and that's the number that goes up above the 10. All right, you got it? Not too bad, huh? Here are the hints. All right, well, that's pretty much it today as we talked about integer exponents. Are you able to answer this question now? How can you find a number with an integer exponent? Pretty simple, huh? All you got to do is take the 1, put it on top, get rid of the negative, and put that on bottom. Well, that's it for today. Thanks for joining us as we talked about integer exponents. This is Matt with mathsmath.com. Join us on Facebook at Solving Maths Problems, or on Twitter, Maths Math. Enjoy math.